This is Dreamtime Science, where tonight's most interesting discoveries become tomorrow's dreams. I've got something particularly engaging to share with you. You know, I've been thinking about how everything around us seems to have a speed limit, but the speed of light feels like the most extraordinary one of all. There's something remarkable about the idea that no matter how hard you try, nothing can zoom faster than light, like the universe's own gentle rulebook. I'm excited to share why that speed isn't just fast, but a kind of cosmic boundary that shapes everything we see and experience. Should these dreamy explorations accompany your journey to sleep, a gentle like or subscription would be deeply appreciated. What questions about our universe keep you wonderfully curious? Now, take a moment. Adjust your blanket. Find the perfect hollow in your pillow. Let your shoulders melt. Breathe in and out. Across the vastness of the night sky, where pinpricks of starlight shimmer and drift behind the gauze of atmosphere, a peculiar yearning has always taken hold in those who gaze upward. It is a longing not just for knowledge, but for passage, to cross those gulfs, to chase the beckoning beacons of distant suns, to slip between the stars as easily as a thought. This restlessness, this desire to outrun the confines of our pale blue world and touch the fabric of the universe itself is as old as our capacity to dream. Tonight, as you settle in, let us begin at the starting line of the greatest race ever conceived, not one of runners or chariots, but of photons, of possibilities, and of the very limits of what the cosmos allows. We will walk, or perhaps drift, onto the cosmic racetrack, a boundary that defines not only how quickly things may move, but how deeply we may peer into the heart of reality. What is this track, this invisible limit, that shapes the architecture of the universe? It is a law written not in ink or decree, but in the language of space and time itself. It is the speed of light, denoted by the humble letter c, the fastest anything can ever go. To the untrained eye, light is just illumination, a means to see the world. But to the physicist, to the poet of equations, light is the swiftest messenger, racing at nearly 300,000 kilometers per second, or about 186,000 miles per second. In the time it takes to blink, a beam of light can circle the globe 7 times. So why should there be a limit at all? Why not faster still? Here, in the soft hush of a darkened room, let's follow the thread of this question as it weaves its way through history and imagination. Long before equations, before telescopes, humans watched the stars and perhaps wondered if there were gods or spirits that could leap from one to another in an instant. As civilization advanced, so did curiosity. The ancient Greeks pondered whether light traveled instantly or took time to traverse distance. It would be centuries before the Danish astronomer Ole Rømer, observing the eclipses of Jupiter's moons in 1676, first glimpsed the finite speed of light, noting discrepancies in timing as the Earth moved closer or farther from Jupiter. Through such patient observation, the universe whispered its secret. Not even the swiftest thing is infinitely swift. The speed of light, as it turns out, is not merely a technical detail, but a foundational pillar of reality. It is the thread woven through every star, every atom, every thought and dream that takes root in a mind alive to the mystery of being. But the human spirit is not easily resigned to boundaries. If there is a wall, we wish to leap it. If there is a speed limit, we imagine breaking it. In the golden age of science fiction, as rockets first split the sky and satellites circled the Earth, writers conjured visions to satisfy this urge. In the universe of Star Trek, the warp drive bends space itself, allowing starships to vault across light years in mere days or hours. The Millennium Falcon, in the mythos of Star Wars, jumps into hyperspace with a shudder and a streak of starlight, leaving the sluggish crawl of conventional travel behind. These stories seduce us because they tap into a primal defiance. Why should the stars remain so far away? Why must we accept the tyranny of distance, the slow creep of time between worlds? The allure of breaking the cosmic speed limit is not just about adventure, but about hope. The hope that the universe might be smaller than it seems, that our reach might one day match our curiosity. Yet the universe, in its silent dignity, enforces its rules. The speed of light is more than just a number. It is built into the scaffolding of space and time itself. When Albert Einstein contemplated the strange behavior of light in his special theory of relativity, he realized that no matter how you chase it, whether you run toward it or away from it, light always speeds away from you at the same relentless pace. This constancy is not just a feature of light, but a principle that shapes the very geometry of reality. Imagine a cosmic speedway stretching from the Sun to the nearest star, Proxima Centauri, 4.24 light-years away. Even at the velocity of light, a journey from our solar system to that modest neighbor would take 4 years and a few months. For the fastest spacecraft ever built by human hands, the journey would take millennia. The distances between stars are not just large, they are staggeringly, almost unimaginably vast. And so, from Jules Verne's Victorian moonshots to the sleek starships of the 23rd century, our fictions have been compelled to invent ways to cheat the racetrack. Warp drives, hyperspace corridors, wormholes. These are not just plot devices, but manifestations of the human refusal to yield to the cosmic order. But what, truly, does it mean to have a speed limit? Why is the speed of light not just a technical hurdle, but a fundamental law? To answer this, let us slow down and examine the nature of the track itself. Einstein's insights revealed that as objects approach the speed of light, time and space themselves begin to warp and twist. A spaceship hurtling ever faster finds that its clocks slow, its rulers shrink, and the energy required for further acceleration grows without bound. To reach the speed of light would require infinite energy, an impossibility, not merely an inconvenience. It is as if the universe itself conspires to keep all massive objects, stars, planets, spaceships, people, forever below this ultimate pace. Photons, the quanta of light, are unique in that they have no rest mass. They are born moving at sea and can go no slower, no faster. For them, time does not pass. Distance collapses to nothing along their path. They are the true racers, the only runners for whom the track is not a limit, but an identity. This hard boundary is not just a constraint on travel, but on causality, on the very possibility of cause and effect. Information cannot travel faster than light. No signal, no message, no nudge or whisper of an event can outpace it. The universe, in this sense, is a tightly woven tapestry of consequences, with the speed of light as the shuttle that binds threads together. Yet in our stories, we try to find loopholes. The warp drive of Star Trek, for instance, does not merely accelerate the ship, it bends the racetrack itself, contracting space ahead while stretching it behind, so that the ship effectively rides a wave of space-time. The ship itself never breaks the speed limit locally, but the distance between points is compressed. Here, scientific imagination intertwines with mathematical possibility. General relativity, Einstein's deeper theory, does allow space-time to warp and curve. Could we, in principle, engineer such a thing? The equations say perhaps, but the requirements, a bubble of negative energy, exotic matter, are beyond anything we can yet conceive. In Star Wars, the hyperdrive accesses a parallel dimension, a subspace highway where the normal rules of speed do not apply. This is not just a technical solution, it is a mythic one, a declaration that the universe is, or can be, more generous than it appears. Science fiction is, in this way, both a mirror and a lantern. It reflects our yearning and lights a path for hope. even if that path is paved in the impossible. There is a peculiar poetry in the fact that as we press against the boundaries of what can be known and done, we find those boundaries not in the roughness of materials or the cleverness of machines, but in the deep logic of the cosmos. The speed of light is not a wall, but a law, one that shapes the horizon of what is possible. Yet even within this law, there are subtleties. In certain materials, light slows. In glass or water, it creeps along at a fraction of its speed in vacuum. But the ultimate limit, c, is defined in the emptiness of space, the purest vacuum where nothing stands in the way. No matter how much cleverness we bring to bear, the speed of light in vacuum is the definitive line drawn in the sand. Physicists have played with the equations, seeking cracks or loopholes. Perhaps, some suggest, there might be particles, tachyons, that always move faster than light. But if such entities exist, they cannot communicate with the world as we know it. They are consigned to the realm of speculation, their reality unconfirmed. Others look to quantum entanglement, where particles seem to affect each other instantaneously across great distances. But here, too, the universe is careful. No usable information can travel faster than light, and causality is preserved. So we find ourselves, as ever, balanced between the starkness of fact and the richness of dream. The speed of light is the cosmic referee, the impartial judge that keeps the race fair, even as we imagine ways to slip past its vigilance. Even now, as you listen, light is racing from your lamp, from the stars outside your window, from galaxies so distant their light began its journey before humans walked upright. Each photon is a traveler, a participant in the oldest race of all. Yet we persist in asking, what if? What if we could break the rules, find a secret shortcut, leap across the yawning distances? What if the racetrack is not as fixed as it seems? Perhaps in the next quiet moment we may linger over these questions, allowing them to settle like stardust on the mind. For the race has only begun, and the journey ahead will take us deeper into the heart of the cosmic speedway, a place where time, space, and possibility intertwine, and where the pulse of light marks both the boundary and the promise of what may yet be discovered. In the silent hours before dawn, when the stars stand as pinpricks on the velvet dome above, it is tempting to think of the cosmos as a frozen tableau, an unmoving, infinite canvas upon which the drama of existence quietly unfolds. But as our understanding has deepened, this illusion of stillness dissolves, revealing a universe in ceaseless motion, woven from threads of time and space that ripple, stretch, and sometimes twist in manners that defy intuition. Time and space, two words so simple and familiar, yet they enclose a complexity that took centuries for the human mind to even begin to grasp. Long ago, time was a river, flowing smoothly from past to future, the same everywhere and for everyone. Space was a stage, absolute and unyielding, where events played out in a shared, unchanging now. These were the assumptions of the classical world, comforting in their certainty, but the universe had subtler secrets hidden in its depths. At the turn of the 20th century, with the ink still drying on the grand equations of Isaac Newton, the first cracks appeared in this classical edifice. The speed of light, c, a finite, unyielding constant, emerged not merely as a property of electromagnetic waves, but as a law written into the bones of reality. No matter how fast a star hurtled through the void, no matter how rapidly an observer chased after a beam, the speed of light always remained the same, an unbreakable universal limit. It is here, at this threshold, that paradoxes begin to multiply. What does it mean for there to be a speed limit in the cosmos? Why should light, among all phenomena, refuse to be overtaken? And what strange consequences flow from this, for time itself? Imagine a rail car, sleek and shining, gliding along a cosmic track. A passenger inside switches on a flashlight, sending a luminous pulse toward the front of the car. Intuition, schooled by everyday experience, whispers that the speed of the pulse should be the sum of the train's velocity and the speed of light itself. After all, if you walk forward in a moving train, your speed adds to the train's. But the universe is not so easily persuaded. An observer outside, motionless relative to the tracks, measures the speed of the light pulse and finds it unchanged. See, no more, no less. The speed of the train, it turns out, is irrelevant. To reconcile this, space and time themselves must bend to accommodate the stubborn constancy of light. This is the strange genius of Albert Einstein's special theory of relativity, unveiled in 1905. The theory's heart is not a complicated equation, but a profound assertion. The laws of nature, including the speed of light, are the same for all observers, regardless of their motion. The consequences are as surprising as they are beautiful. If the speed of light cannot change, then something else must. And so time slows down for the moving rail car, while distances along its direction of travel shrink. These are not illusions, nor mere quirks of perception. They are the fabric of reality, revealed by experiment and observation. Time and space, once thought absolute, become fluid, intertwined, and responsive to motion. Let us dwell for a moment on the phenomenon of time dilation, so often misunderstood and mischaracterized. Suppose you could sit inside a spaceship, accelerating ever faster, approaching the speed of light. To you, time ticks on as usual. Your heart beats in its familiar rhythm, your thoughts drift and return, undisturbed. But to a distant observer, standing still relative to your ship, your movements slow, your clock ticks more and more languidly. The faster you travel, the more pronounced this effect becomes. At the speed of light itself, if you could ever reach it, which you cannot, time would stand utterly still. This is not merely philosophy, but an empirical reality. Muons, elementary particles created in Earth's upper atmosphere, decay in microseconds. Yet those moving at relativistic speeds, close to light, survive far longer as measured from the ground, their fleeting lives stretched by time dilation. For them, the journey to the surface is over in an eye blink. For us, it is prolonged, as if time itself conspires to let them finish their descent. But what of the ancient dream, to exceed the speed of light, to slip the bonds of sea, and perhaps to travel backward through the corridors of time? Here the tapestry grows even more intricate, and the edges of myth and reality begin to blur. The notion that surpassing the speed of light would let one journey into the past is a surprisingly persistent myth, fed by science fiction and the seductive symmetry of time's arrow. It arises in part from the equations of relativity themselves. If you imagine purely as mathematics a velocity greater than c, certain quantities, such as time intervals, become imaginary numbers, their square roots negative, their physical meaning suspect. In some frames, an event that occurs after another could be seen as happening before it. It is as if the sequence of cause and effect could be jumbled, unmade. But mathematics is not reality, and the universe is not so easily coaxed into contradiction. The laws of physics, as we know them, conspire to prevent any object with mass from ever reaching, let alone surpassing, the speed of light. As you accelerate, your mass, your resistance to further acceleration, increases without bound. The energy required to push you ever closer to C approaches infinity. No conceivable rocket, no matter how mighty, could provide the requisite thrust. This, then, is the first and most profound barrier. The universe brooks no trespass beyond the light speed threshold. And even were you to imagine some loophole, some hypothetical particle called a tachyon that always moves faster than light, you would find yourself mired in paradox. Tachyons, if they existed, would violate the stability of causality. They would allow messages to be sent backward in time, undermining the very scaffolding of cause and effect. Yet, for all our probing, we have never glimpsed such particles, and their existence remains a speculative curiosity, unsupported by evidence. The confusion deepens when one considers the malleability of simultaneity itself. In relativity, the notion of now is not absolute. Two observers, moving relative to each other, will disagree about which events are simultaneous. What is present for one may be past or future for another. Yet this does not provide a gateway to the past, but a shifting perspective on the unfolding of time. The sequence of cause and effect is preserved. The arrow of time remains unbroken. Consider the so-called twin paradox, another jewel in relativity's crown. One twin remains on Earth, while the other embarks on a journey close to the speed of light. Upon return, the travelling twin has aged less than their sibling, a consequence of time dilation. But at no point does either twin move backward in time. The past remains unreachable, forever receding as experience accumulates. No matter how swift the journey, the arrow of time points inexorably forward. Myths once born are hard to dispel. The alluring idea that faster-than-light travel could allow us to revisit lost yesterdays is stubborn, perhaps because it resonates with a deep yearning to undo mistakes, to see departed loved ones, to relive moments now vanished. Yet the universe, for reasons woven into its deepest geometry, denies us this power. The fabric of space-time is constructed so that causality, the order of cause and effect, is preserved. The past is a country we may remember, but never again visit. Still, the cosmos is not without its enigmas. There are solutions to the equations of general relativity, Einstein's grander, more encompassing theory, that seem to permit closed time-like curves, pathways through space-time that loop back upon themselves. These are the stuff of wormholes, rotating black holes, and hypothetical cosmic strings. But such constructs, if they exist at all, are fraught with caveats and contradictions. They may require forms of matter with negative energy, which have never been observed. They may be unstable, collapsing before they can be traversed. Even in these exotic realms, the universe seems to conspire against easy journeys to the past. Returning to the everyday, we find that the light speed limit is not a curse, but a guardian of order. It ensures that information, and thus causality, cannot be disrupted. The messages we send, the signals we receive, are bounded by C, preserving the sequence of events and the integrity of history. The speed of light is not merely a number, it is the scaffolding upon which reality is built. And yet, there is beauty in the boundaries. The interplay of time and space, the way they warp and flow in response to motion, provides a richer, more nuanced universe than we ever imagined. The twin paradox, the dilation of time, the contraction of space, all are reminders that reality is deeper and subtler than our senses alone reveal. There is one more subtlety, often overlooked amid the grandeur of relativity. The speed of light is not just a speed, it is a conversion factor, a bridge between space and time. In the equations of physics, c allows us to translate distances into durations, to see that space and time are two faces of the same underlying reality. We move not through space alone, but through space-time, a unified, four-dimensional tapestry in which every event is a point, fixed by its position and its moment. To travel faster than light, then, is not simply to move more swiftly. It is to attempt to step outside the very structure of space-time. The laws that govern the universe are written in such a way that this is not permitted. The paradoxes that arise from imagining otherwise are not signs of deeper possibility, but warnings, red flags that mark the boundaries of what is physically meaningful. Let us linger, then, in this wondrous space between myth and mathematics, where the mind stretches to grasp realities that elude our everyday experience. The cosmos is a vast and intricate tapestry, its threads woven from the interplay of time and space, light and causality. There are mysteries aplenty, paradoxes that challenge and delight, but always the speed of light stands as the sentinel at the threshold, allowing us to explore, to wonder, but not to trespass. Even as we dream of voyages to distant stars, or imagine the whispers of civilizations yet unknown, we are bound by this cosmic speed limit, this gentle but unbreakable law. It shapes not only our journeys, but our understanding of what is possible, of how the universe unfolds moment by moment across the infinite expanse. In the deep hush of night, as you close your eyes and let your thoughts drift outward, consider this. Every photon that reaches you from a distant star has obeyed the same law, traveled the same universal speed, crossed the same interstellar darkness. The light you see tonight began its journey perhaps before you were born, traversing vast gulfs of space and time, carrying with it the story of worlds unseen. The infinite tapestry of time and space stretches on, each thread a record of what has been, each intersection a heartbeat in the life of the universe. The speed of light weaves through it all, a silent, steadfast guide, ensuring that the past remains memory, the future remains possibility, and the present is ever new. But there is more yet to ponder. If time and space are so intimately bound, if motion can warp the very flow of moments, then what happens near the places where gravity itself bends reality to its will? What becomes of time at the edge of a black hole where even light cannot escape? The tapestry grows more intricate still, and the story beckons us onward into the realms where space and time themselves are stretched to their limits. In the gentle hush of a world settling into twilight, the human mind has always found itself drawn to the mysteries that lie just beyond the reach of ordinary sight. The speed of light, an ethereal constant, swift as thought and silent as the void, has beckoned, tantalized, and eluded certainty for centuries. To unravel this cosmic thread, generations of thinkers have marshaled not just their senses, but their ingenuity, patience, and wonder. And each experiment, each instrument, each calculation is a whisper in the great conversation between human curiosity and the universe's subtle truths. Let us drift now into the workshop of Galileo Galilei, a mind restless beneath Florentine stars. It is the early 17th century, and the world is only beginning to accept that there are laws to nature, rules that can be discovered and tested. Galileo, bold and ever unsatisfied with the boundaries of received wisdom, ponders whether light travels with infinite speed or with some measurable swiftness. His experiment, simple in vision yet monumental in intent, calls for 2 lanterns and 2 observers stationed atop distant Tuscan hillsides. Each holds a lantern, its flame shrouded until the appointed moment. The plan is delicate. One observer uncovers his lantern, and as soon as the other sees the flicker, he reveals his own in reply. Galileo times the interval between his action and the returned signal, hoping to catch the lag, however slight, that would betray light's finite pace. Yet the world is not ready to yield its secret so easily. The distance between the hills, though spanning hundreds of meters, is but a blink to light, which covers that space in less than a millionth of a second. Human reflexes, sluggish and uncertain, blur any fleeting difference between action and response. Galileo concludes, with a sigh softened by the night breeze, that if light's speed is not infinite, it is at least fantastically great. This first attempt, though inconclusive, is not a failure. It plants a seed, a conviction that nature's veils can be parted with cleverness and care. The centuries turn, and the question travels northward, across the sea and into the mind of Ola Roma, a Danish astronomer with a gift for patience and a love for the clockwork ballet of the heavens. Roma's laboratory is the sky itself, and his instrument is the dance of Jupiter's moons. He notices something curious. The eclipses of the innermost moon, Io, do not occur at perfectly regular intervals as Jupiter orbits the Sun. When Earth is moving away from Jupiter, the eclipses seem to lag behind schedule. When Earth draws closer, they arrive a little early. Roma, with careful records and a clock attuned to the rhythm of the stars, realizes what he is witnessing. Light, though swift, takes time to cross the increasing or decreasing gulf between planets. His calculations, born of months spent peering through a telescope's narrow window, yield a value for light's speed, roughly 220,000 kilometers per second, an estimate marvelously close for its day. For the first time, the cosmos is measured not just in distances, but in delays, a universe where events in the sky ripple to us across the void, each a message written in light, arriving ever so slightly after it was sent. With this revelation, the very fabric of reality seems to quiver with possibility. If light takes time to journey from star to eye, then every glance at the night sky is a look into the past, each twinkle a memory of a moment already gone. The universe, it seems, is not merely vast in space, but deep in time. The tools sharpen. In the 19th century, French physicist Hippolyte Fizeau devises a more earthly experiment, one that brings the elusive speed of light within the reach of human hands and clever machinery. Fizeau's apparatus is a marvel of wheels and mirrors, light and shadow. He shines a beam of light through the gaps in a rapidly spinning toothed wheel, sending it across a measured distance to a mirror. The light reflects back, and if the wheel turns just so, the returning beam is blocked by a tooth, not a gap, proving that the wheel has rotated during the light's round trip. By adjusting the speed of the wheel and the distance to the mirror, Fizeau finds the speed at which the returning light and the wheel's teeth align perfectly out of phase. From this delicate choreography, he calculates the speed of light with remarkable precision. The numbers are no longer just guesses or cosmic inferences. They emerge from the interplay of matter and motion, of gears and gleam. The answer sharpens, about 313,000 kilometers per second, inching closer to the truth. Soon after, Léon Foucault refines Fizeau's experiment by replacing the wheel with a rotating mirror. The beam's reflection shifts ever so slightly depending on the time light takes to travel out and back, a displacement that can be measured with ever greater accuracy as the mirror's speed increases. Foucault's method, elegant and less prone to mechanical error, yields a value astonishingly close to our modern understanding. Throughout these centuries, the measurement of light's speed is a story of persistence and refinement, of errors whittled away by each new insight. The methods become more subtle, the apparatus more precise, but always the pursuit is the same, to catch the swiftest thing in the universe, to pin its value to the page. With the advent of the 20th century, the very nature of light and time itself comes under scrutiny. Albert Einstein, haunted by the implications of Maxwell's equations and the failure of all attempts to detect a stationary ether through which light might propagate, posits in his special theory of relativity that the speed of light is not only finite but absolute, a cosmic speed limit, the same for all observers, no matter their own motion. This declaration is both a revelation and a riddle. It means that time and space themselves must bend to accommodate the constancy of light's speed. As a result, scientists begin to devise experiments that probe not only the speed of light itself, but the strange consequences of approaching it. Before we leap into the realm of thought experiments, we find ourselves in modern laboratories where lasers replace lanterns and atomic clocks tick with a precision undreamed of by Galileo or Roma. Here, the measurement of light speed is not just a triumph of patience, but of technology. A laser's pulse, sharp and unwavering, can be split and sent along two paths, each of precisely measured length. The returning flashes are compared using photodetectors and oscilloscopes, instruments so sensitive they can capture intervals of mere billionths of a second. The atomic clock, meanwhile, is a marvel of quantum regularity, its rhythm set by the transitions of electrons within cesium or rubidium atoms. These clocks are so precise that they would lose or gain less than a second over millions of years. With these tools, scientists can measure the time it takes for light to travel a known distance with breathtaking accuracy. The result, fixed now at exactly 299,792 458 meters per second, is used to define the meter itself, a unit of length pegged not to a bar of platinum in Paris, but to the unwavering pace of light in a vacuum. Thus the speed of light becomes not just a measured quantity, but a pillar upon which the very system of measurement rests. But the measurement, for all its marvel, is only part of the story. The true wonder arises as we push our imaginations further into the domain of thought experiments, those mental laboratories where the rules of reality can be twisted, stretched, and illuminated without the need for apparatus at all. Consider the famous train paradox, conjured by Einstein to probe the consequences of light's unyielding speed. Picture a train gliding smoothly along its tracks, and atop it a passenger flashes a beam of light toward the front and back of the carriage. To the passenger, ensconced within the train, the light races away from him at its usual speed in both directions. But to an observer standing beside the track, the train's motion must be taken into account. If light's speed is truly the same for all, then something else must give way. Time itself must slow down for the moving train, distances must contract, and simultaneity must become slippery and relative. This strange elasticity of time and space is no mere mathematical oddity. It is borne out in the ticking of atomic clocks carried aboard jets, in the gentle drift of GPS satellites as they circle the Earth. Their clocks, moving swiftly and far from the planet's surface, tick at a slightly different pace than clocks on the ground. The difference, minute but measurable, must be corrected lest our navigation systems go awry. Thus, the consequences of light speed ripple through the infrastructure of daily life, bending the flow of time itself. Another mental voyage awaits in the twin paradox, a favorite among physicists and storytellers alike. Imagine twins, one of whom boards a spacecraft destined for the stars, accelerating to speeds near that sacred limit, while the other remains on Earth. Upon the traveller's return, she finds her sibling aged more than herself. The passage of time has stretched and warped under the strain of velocity, as predicted by relativity. The paradox is resolved not by magic, but by the rigorous logic of equations that trace the path of light through space-time. Such thought experiments do not merely illustrate the strangeness of the universe. They offer a deeper insight. The speed of light is not just a physical constant, but a rule that shapes reality at its most intimate level. As we approach this velocity, the familiar scaffolding of experience, distance, duration, order begins to dissolve and reform into new and unfamiliar patterns. And yet, the story is not finished. Modern physicists push the boundaries further, probing the speed of light with ever greater subtlety, searching for hints of its variability in the early universe or in the tangled fields of quantum gravity. Some wonder whether, in the crucible of the Big Bang or in the heart of a black hole, the rules might shift and light's swift pace might flicker ever so slightly. In far-flung laboratories, beams of laser-cooled atoms are sent racing through vacuum chambers, their trajectories measured with exquisite care. Experiments seek to catch the whisper of a photon's delay as it passes through a cloud of gas, or to compare the speed of light at different energies, searching for cracks in the edifice of relativity. Each result, each null finding, is a thread woven into the tapestry of our understanding. At the same time, theorists conceive of new experiments, Could we perhaps detect the faint tremor of a gravitational wave, a ripple in space-time itself, by watching the dance of laser beams in kilometre-long arms, as in the LIGO Observatory? Here, light becomes not just a messenger, but a ruler, measuring the undulations of reality itself. As we lie under the stars, the tools and experiments of generations past and present gather around us like a constellation of ingenuity. Each lantern, each wheel, each clock, each laser is a point of light in the ongoing human quest to understand the cosmic threads that bind us to the universe. The speed of light, once a distant mystery, now pulses at the heart of our science, our technology, and our very sense of time. But the quest does not end here. The more we measure, the more we imagine, the more the universe seems to invite new questions, new paradoxes, new frontiers. The night stretches on, and with it the call to venture deeper, to follow the light wherever it may lead, into the fabric of space, the flow of time, and the mysteries that still await in the gentle hush between each heartbeat of the cosmos. The speed of light, so often uttered as a number, 299,792, 458 meters per second, can seem, at first, a mere technicality. Yet it is a boundary stitched into the tapestry of the cosmos, a limit both humbling and intimate. It is the silent arbiter of causality, the unseen hand that shapes the rhythm of the universe, and an ever-present thread running through our lives, whether we gaze through telescopes or down at the glow of a screen. Tonight we follow that thread, tracing light's journey not merely as a physical phenomenon, but as a bridge between the distant and the near, the ancient and the immediate, the knowable and the mysterious. To begin, let us dwell for a moment on the profound unity woven by the speed of light. All the starlight that caresses our eyes on a clear night began its voyage eons ago, each photon a silent courier from a chapter of cosmic history. When you look up at the star Sirius, the brightest in our night sky, you are seeing it as it was over 8 years in the past. Its photons have travelled some 70 trillion kilometres to reach your retina, preserving within themselves a record of a moment now long vanished from the star itself. The Andromeda Galaxy, a smudge in the autumn sky, is a relic from 2.5 million years ago. Its light began its journey when our ancestors first learned to shape stones. This is not just a poetic happenstance, but a consequence of the ultimate speed limit. Light's finite velocity means that the farther we look, the deeper we peer into the past. The universe becomes a vast, natural archive, every patch of sky a time machine. Our telescopes, from backyard reflectors to the behemoth mirrors atop remote mountains, are not only instruments of sight, but witnesses to epochs we can never touch. The cosmic microwave background, that faint afterglow suffusing all space, is itself a whisper from the birth of the universe, a fossil record of light set free when the cosmos was only 380,000 years old. The speed of light, then, does more than limit how fast things move. It sculpts our perception of reality. It means there is no now that unites the universe. Each place, each person, each star is always a little out of sync, their moments staggered by the time it takes light to travel from one to another. The world you see is always an echo, a collection of pasts stitched together. When you glance across a room, you are not seeing your companion as they are, but as they were a tiny fraction of a second ago. In the grand cosmic scale, that lag becomes profound. Galaxies, nebulae, even the sun, are all rendered in the language of delay. Yet, within this tapestry of delays lies a deep connection. The speed of light is the same for all, everywhere, always. It does not discriminate. Whether a photon is born in the fiery heart of a distant quasar or in the simple flicker of a candle, it honors the same limit. This constancy is not merely a technical feature. It is the bedrock upon which the universe's order rests. All of physics, from the laws governing atoms to the dance of galaxies, must bow to this rule. It is the heart of Einstein's relativity, the reason that no signal can outrun causality, the reason that space and time themselves are woven together in a single, interdependent fabric. This unity has a curious consequence. The speed of light connects us to everything, but always at a distance. We live in a universe where information, love, warning, and wonder all propagate at the same ultimate pace. There is no way to leap ahead, no shortcut. If a star were to vanish in a far-off galaxy, its absence would remain unknown to us until the last photon arrived, perhaps billions of years hence. Even on Earth, the signals that carry our voices and images, radio waves, fiber optic pulses, the silent flicker of LEDs, are all bound by the same speed. We are all participants in this grand relay, each of us both receiver and sender in a cosmos where nothing is truly instantaneous. And yet, for all its rigidity, the speed of light is also the enabler of all connection. Without it, there would be no way for energy, information, or causality to cross the gulf between separate places. Light allows the sun's warmth to reach us across 150 million kilometers, its photons bathing the earth in energy that fuels every plant, every animal, every act of life. It carries the images of our loved ones across the globe, stitched together pixel by pixel, frame by frame, so that distance is softened, if never quite erased. It encodes the stories of atoms and galaxies, inscribed in the spectrum of colors we see and the invisible bands beyond our sight. Every act of seeing, every act of knowing, is a negotiation with light's immutable pace. Consider, for a moment, how light's limit shapes not only our science, but our sense of time and self. The universe is vast beyond reckoning, so broad that even at light speed, a message between stars would take years, centuries, or millennia. We are, in some sense, isolated islands, each of us living within our own light cone, a term physicists use to describe the region of space and time that can influence or be influenced by a given event. Our histories are bounded by the intersection of these cones. What we can know, what we can affect, are both delimited by the speed of light. But this boundedness is not a prison, it is a canvas for curiosity. The very fact that we cannot see everything, that the cosmos reserves some secrets behind the curtain of cosmic distance, is what gives rise to wonder. We peer into the night, not knowing what we will find, because we are always and forever seeing the universe as it was, not as it is. Each sunrise, each new discovery, is a fresh encounter with the past, an invitation to imagine what lies beyond the horizon of the visible. There is a gentle paradox here. Light's limit is the universe's law, and yet our minds are not so constrained. We can imagine faster than light travel, teleportation, communication that leaps the interval between moments. Our stories and dreams, from science fiction's warp drives to the yearning for instant connection, are born in the space between what is possible and what is conceivable. In this way, the speed of light becomes not only a physical limit, but a spur to creativity. We dream across the cosmic gulf, inventing new ways to reach out, to know, to belong. In everyday life, the reach of light's poetry is subtle but ever-present. Every sight you behold is a tapestry of photons, each carrying information from the world to your mind. The blue of the sky, the green of leaves, the gentle hue of a loved one's face, all are products of light's journey, shaped by the laws of optics, scattering and absorption, but ultimately reliant on the constancy of that speed. Even the mundane act of reading a page or watching a screen is an act of communion across time and space, mediated by photons that have traveled, if only for nanoseconds, from source to eye. The speed of light also sets the scale for the technologies that define our era. The Internet, that intricate web of fiber optics and satellites, is limited by how fast signals can traverse the globe. In the time it takes for a message to cross the Pacific Ocean, light can only circle the Earth about 7 times. For those who craft global networks, design spacecraft, or dream of interstellar communication, the speed of light is both a challenge and a guide. It shapes the architecture of our machines, the rhythm of our conversations, the very way we plan and dream. In the quantum realm, the speed of light is no less fundamental. Even as particles flicker in and out of existence, even as entanglement seems to promise spooky action at a distance, no usable information can be sent faster than light. The universe is consistent, its rules unbroken. And yet, within those rules, quantum mechanics whispers of deeper mysteries, uncertainty, non-locality, the subtle interplay of potential and actuality. The speed of light does not silence these mysteries, it frames them, providing structure to their dance. There is a certain humility that comes from contemplating this limit. We are not the masters of the cosmos. We are participants in a story written in light, our lives shaped by a speed we did not choose and cannot exceed. But within that constraint lies a hidden freedom. Because we cannot see everything at once, we are invited to explore, to seek, to wonder. Each discovery is hard-won, each understanding the product of patience and imagination. The cosmos does not yield its secrets quickly, and so we learn to savor the slow unfolding of knowledge. This slowness is itself a kind of gift. In a universe where everything happened at once, where all information was instantaneous, there would be no room for story, for suspense, for the gentle arc of inquiry. The delay imposed by light speed is the source of all narrative, all anticipation, all growth. The stars rise each night, not because they move, but because the earth turns, and light from ages past streams in to greet us anew. The seasons change, the planets wander, comets blaze across the sky, all in rhythms governed by distance and time. We are, all of us, dancers in light's slow ballet, each step measured by the beat of that universal limit. Yet for all the grandeur of the cosmos, the most profound light may be that which illuminates our own hearts and minds. The photons that reach your eye, the gentle pressure they exert, the cascade of electrical impulses they trigger, these are the basis of perception, memory, and meaning. Light becomes sensation, sensation becomes thought, thought becomes wonder, and wonder, unlike light, is not bound by speed. It leaps across epochs, imagines worlds unseen, connects mind to mind across generations. In the end, perhaps the most poetic truth is this: the universe is governed by limits, but our capacity to reflect upon those limits is not. The speed of light binds the cosmos together, but it cannot constrain the reach of imagination. Every child who looks up at the stars, every scientist who builds a new telescope, every artist who paints with the colors of the spectrum is participating in a limitless act of communion. We are joined not just by the photons that pass between us, but by the questions we ask, the stories we tell, the dreams we dare to dream. So as you rest tonight, consider the gentle paradox of light's poetry. The universe is vast, and we are small. The speed of light is swift, yet never fast enough to unite all things in a single moment. But within that limit lies the possibility of connection, the beauty of discovery, the promise that every act of seeing and knowing is part of a grand, unfolding story. There is more to learn, more to question, more to glimpse as the future's light slowly arrives. The stars will continue to send their messages, the photons will journey on, and though we may never reach the edge of all that is, our search will illuminate far more than the distance between worlds. Somewhere deep in the night, as you drift towards sleep, the light from ancient stars will still be crossing the void, carrying with it the memory of beginnings and the promise of tomorrows yet unseen. The universe, it seems, will keep singing its luminous song, and we, bound by the speed of light but unbounded in wonder, will listen and dream and wait for the dawn. As our journey through the shimmering veil of light's swiftest dance drifts to a close, we find ourselves cradled in the quiet hush where cosmic wonders softly glow. Like a comet tail fading into the vastness, the mystery of the speed of light invites us to rest in its gentle embrace, dreaming of the universe's endless secrets. When your heart is ready for more starry tales, return with me to wander once again through the infinite night.